Welcome to a tutorial video in Twine 2.1. In this video I'm going to cover a space exploration example in Snowman 1.3. Now this video is part of a set of videos that explores how to create this example game, space exploration, in each story format as part of 2.1. So there's an example of how to do this in Harlow, an example of how to do this in SugarCube, and this is an example of how to do this in Snowman. And links to those will be in the description of this YouTube video. So this space exploration example borrows heavily from games like FTL, where randomly generated obstacles prevent the player from her goal. So our narrative premise is that our ship has taken damage while in a hazardous area of space. With the navigation system broken, you know that it will take 15 hyperspace jumps to make it out of the area and back to safety. So what are our mechanics here? So our game rules is that each hyperspace jump takes 1 unit of fuel. So every time we take a hyperspace jump, we lose 1 unit of fuel. Because the navigation system is broken, each jump will land us in a random system of 1 to 4 planets. Those marked in red are high risk, high reward. Those marked in green are low risk, low reward, and the chance of red or green is 50%. So we start with 20 health, and we start with 2 units of fuel for a ship. So we need to explore space, we need to explore planets, and we need to try to make our way across the hazardous area of space. So within the editor, the passage programming the rules has a lot more content, and we'll look at that in just a second. So let's explore space 1. So the things we see here are a link to hyperjump, which allows us to hyperjump to a new system at the cost of 1 unit of fuel. However, we also decrease the number of jumps left. So we see here in this randomly generated system that we just have 1 red planet. So we click on it and we see a hostile ship attacked and we lost 2 health. So let's hyperjump. So we see here 2 planets with red and the number of jumps left is 13. Our health is 18 because we were attacked and our fuel is 1. Oh, so we lost some health but we gained some fuel. And we lost some health. So hyperjump again. We see red. And we lost some health again. Well, it's about to be bad, because with 1 fuel left, when we hyperjump, we landed in a new system and we have no fuel to leave, so we tumble and spun in the endless black game over. That's what we get for a randomly generated game. So let's look at the code here. So I'm not going to explain the start passage, because it just points to programming the rules. Programming the rules, however, has a number of different complex things going on, and the reason for that is that Snowman doesn't have any macros built into it. It has some API functionality, which I'm going to cover here in just a moment, but we have to build a lot of the functionality ourselves. So the very first thing we're doing here is we're borrowing a technique from SugarCube story format, and we're making a global variables. So Snowman does provide a story state object, some functionality to access that. So we're building here story state variables, which doesn't normally exist, and setting it to an empty object. We're then setting a shortcut here of the variable vars with an underscore to that. So story state variables. Now the reason we're doing that is to create global access to that. And the reason why we're doing that is that normally within this script element here from the start, very end here, will get run within this scope. Each passage will get run in a different functional scope, which means we can't access variables like we can in other story formats globally, because they won't exist. They'll only exist within their local scope. A way to get around that then, and to borrow a technique from SugarCube, is to create global variables that we can access and locally scope them, use them in a local context within each passage, by referencing them in different ways here. And so that's what we're doing. So the very first thing we're doing is we're starting an object of variables, then we're setting health, fuel, system, and number of jumps left. Now as I said, we set health to 20. We're setting the initial fuel to 3, and the reason why we're doing that is because when we get to the next passage, we're going to lose it by 1. And we're setting system to be an empty array, and setting a number of jumps left to be 15. Now this should actually be 16 when we get to it, because it will decrease by 1 when we show it, which will make more sense when we look at that. So the very next thing we're doing, that is a similar thing. We're also borrowing another technique from other story formats and creating some global functions for the very same reason. And we're actually doing that for a reason I'm going to describe when we get to those passages, to draw down the complexity of using this. So again, we're creating on story state, which is global, existing from the API provided by Snowman, creating a property functions that is an empty object, creating a shortcut here, functions is equal to this, and then we're building two functions, red outcome, and down here, green outcome. So within each of these, we're setting the two outcomes that can happen, either a red planet or a green planet. And we're doing the same thing here, setting a shortcut, we're setting a percentage. Now this usage right here is because the underscore JavaScript library is part of Snowman. And so we can call underscores functionality, underscore, and then whatever function as part of that, because it's available within all of our JavaScript within a Snowman story. So then we're setting response to an initial empty string. If the percentage is, so from 1 to 10, the percentage is greater than or equal to 6, we're setting found health to a random number, found fuel to a random number, and then we're decreasing health and adding fuel each time, because this is a red planet, so it's high risk, high reward. So we can lose a lot of health, but we can also gain some fuel. And we're setting response to what that was. So the hostile, and then the value here, and the value of the variable here, so a full string response. Else, and the same thing with percentage is less than or equal to 3, the same general idea. So found health is equal to some random number from 2 to 7, and then we decrease it here. If neither of those things happen, if percentage is not greater than or equal to 6, or percentage is not less than or equal to 3, then nothing happened and we set that response. And then we return that response, which will make more sense here in just a moment when we go look at that. For green outcome, we do the same thing. We check the percentage, we add some random numbers, we show the outcome, and we return the response. So let's go look at Explore Space 1, which is where things start to happen. So Explore Space 1 and Explore Space 2 both have a division element that wraps all of this internal stuff with a class set to game screen, which will make a little more sense when we get later into this, and you'll see why I did that. Now we're using underscores template functionality here, which is what the less than and the percentage sign means here. So the very first thing we're doing is we're saying, okay, create another local reference vars to story state variables. We're going to decrease the fuel by 1, and we're going to decrease the number of jumps left by 1. This is what this minus minus means. And then we're going to create a link to a new passage. We're going to say it's the word hyperjump, but it's actually a link to Explore Space 2. Down here, we're creating a division element with the ID of HUD and setting it to the content of the passage HUD. Now this right here is similar to SugarCube or Harlow's use of, and Harlow display and SugarCube include, where we're rendering the content of the passage HUD, then we're using underscores template functionality to show that show the value of that response right here. So with underscore, using the equal sign right here, right next to it, of the template functionality, we can show somewhere outside of a script element a value of something. And so we're getting the HTML rendered content of the passage HUD, and we're showing it right here. Now let's pause right here to go look to see what that passage shows. So in HUD, this passage does a very similar thing and uses that same underscore template functionality to show values here. So that we have the word health and then the value of the variable health. Now health is part of variables, which is part of state, which is part of story. And instead of creating a shortcut here, we just use the full expanded name. So health of variables of state of story, fuel of variables of state of story, and we're showing those values. And then we're showing the number of jumps left as well. And as we saw in practice, it showed us health, it showed us fuel, and showed us number of jumps left. So okay, coming back to Explore Space 1, we see, okay, this shows us our health, our fuel, and our number of jumps left. And the next thing we're doing is we're rendering generate system. This is similar to, in the way I just explained, the use of the display macro in Harlow or the include macro in SugarCube as a way to render something, that is, get the content of some other passage and show it in another passage, which is what we're doing here using the underscore template system to show the value returned by the rendering of the passage with the name generate system. So let's go look at generate system. So generate system here uses the script element right here to run some JavaScript. So again, we're setting a local reference to the global story state variables. We're setting planets to using underscores random function, a random number from 1 to 4. We're changing system, which is now a global within the Snowman example, to a new array of size, whatever, from random 1 to 4. Then, using a for loop here, from 1 to the length of system, so whatever system's length was set to, we're setting internally each index, system I, so from 0 to whatever number it was set to sample red or green. Now, the sample function within underscore works similar to the either macro within Harlow or the either function within SugarCube. So it returns 1 from whatever you send it. So in this case, we're sending an array with 2 entries, red or green. So it will return a sample of red or green because there's only 2 of them. And so we can reconfirm here our mechanics that we established at the beginning of this, that each system here, or each planet within a system, will be red or it will be green, acting, as I said, similar to the macro usage of either within Harlow or the either function within SugarCube, using underscore functionality here that's available as part of Snowman. So we're building an array system with values of strings either red or green for generate system. Coming back to Explore Space 1, we see the next thing that happens is the use of a division with the ID display. And we see display system and check status. So the next thing that we'll look at after we've generated a system is to display that system. So let's go look at display system. So display system also uses some JavaScript here, starting here and running to the very bottom. So again, setting a local reference to the global story state variables. And then the next thing we're doing is we're wiping out, if it has any, the current contents of any element with the ID display. Now the reason we're doing that is because we're about to add to that in just a second, and we want to make sure there's nothing there from any previous loops we might have gone through. Very next thing we're doing is we're going through the length of system for however many we set it to, 0 to a maximum of 4, and we're testing those each time. Now notice here we're actually using some jQuery, which is another JavaScript library that is available within Snowman. It's also in fact available that is, within Harlow and SugarCube as well, although less likely to be used because of the extensive number of macros that are available in those other story formats. However, because macros are not available within Snowman, we can use jQuery along with the underscore we've already been using functionality to build some of that same macro functionality in our own way using JavaScript. So we're currently wiping out the contents. Then we're going to move through however many planets there are within the system, and then we're checking 2 different things here. We're checking if the excuse me, if the content of the index I of system is red, then we're doing these things. Now this is some complex jQuery here, because what we're doing is we're replicating functionality that's available within Harlow and SugarCube. It was the link macro within Harlow and the link replace macro within SugarCube that we're replicating here by using jQuery to create a hyperlink reference to an empty hash, so don't link to anything, with the word red. Then we're tagging it with, or adding a trigger functionality for click. So if this link is clicked, then replace this, so whatever was just clicked, with the content of the passage show outcome red as rendered into HTML. Then we're returning false so that nothing else happens and that the default functionality doesn't do anything. We want to run that, and we want to use return false here, because otherwise the Twine editor is going to interpret when it plays it as clicking on a link, and you then get really confused because this isn't actually a link to anything. So we stop the default functionality. So we create a hyperlink with the word red, and then we wait to see if it's clicked. If it's clicked, we replace it with show outcome red, and then we append link. So display has this all here, and then we append a break rule so that there's a so it says red or green on each new line. Finally, down here in green, we do the exact same thing, but now we do it for green instead of red. So we do green, show outcome green, return false, append that to display, append a break line, or a break rule, that is. So let's go look at show outcome red and show outcome green. Now show outcome red within the Snowman example actually gets compressed and is much simpler looking than it was in the Harlow or Sugar Cube examples if you go look at those. And the reason for that is that we moved all of the functionality into a function that is part of story state to make this easier to run here. Then we're using underscores again, template functionality, to return whatever this outcome is. So let's go look at red outcome function that's within programming the rules. So the red outcome function, this right here, and as I described earlier, gets a random number, tests that random number, and then adjusts health and fuel accordingly. Then returns whatever their response is. So we will return some type of response here, and then using underscores template functionality, we call jQuery this time on an element with the ID HUD. We change its HTML to Windows Story Render of the passage called HUD. Now this whole section right here works the same as if it was the replace macro in either Harlow or Sugar Cube, acting to replace the content with some other passages content in the same way. Finally here, we're checking the status using underscore template functionality, Windows Story Render of the passage with the name check status. Now let's go look at check status. Check status first creates a local reference to the global variables, then sets the variable status to an empty string, and then checks. Okay, if our health is less than or equal to 0, we're going to look at destroyed. If our fuel is less than or equal to 0, we're going to look at lost in space. Or if our number of jumps is less than or equal to 0, we can look at safe. Now let's pause looking at check status and go look at those three. So destroyed, very straightforward. The ship exploded in flight, game over. If it was lost in space, without fuel, the ship tumbled and spun in the endless black, game over. Or if it's safe, after 15 hyperjumps, the ship left the hazardous area and called for help. Success! So we see within check status that the Windows Story Render returns the HTML rendered results of one of those passages. However, down here, we check to see if status actually changed. Because if health is greater than 0, and if fuel is greater than 0, and if number of jumps is greater than 0, then we're not looking at any of those, and status didn't change. So if status is not equal to an empty string down here, then using jQuery, we look for any elements that have the class of game screen. Then we change its internal HTML to status. So in this case, with check status, let's go back to Explore Space 1, and we see the entire thing is wrapped in an element with the class game screen. Now this is also true of Explore Space 2. And the reason, as I described earlier, we finally caught back up to, and it's because of check status. So check status allows us to achieve the same result of the go-to macro within Harlow or SugarCube by replacing the entire content that we were just looking at it with the content of some other passage. In this case, using check status, destroyed, lost in space, or safe, or if none of those happened, nothing at all. So we can replicate the same result of go-to macro, of going to some passage, in or from Harlow or SugarCube by replacing everything we wrapped it in, by looking for an element that wraps all of our previous Explore Space 1 or Explore Space 2 content. Okay, so let's go back to show outcome red. So that was our last thing. So we looked at, we check our outcomes, we update our HUD, and then we update our status. And show outcome red and with show outcome green, which basically do the same thing here. We either red or green outcome, calling those functions that we defined globally as part of programming the rules. And so finally you see within Snowman here, using a combination of JavaScript and the underscore library and the jQuery library, that we can in fact replicate the same functionality, and you'll see links to those different videos within the YouTube description, of Harlow and of SugarCube within Snowman. And for this other videos that also explain the same example, you can see the different ways of implementing that, and as I've discussed in Snowman, the differences between Harlow and SugarCube and Snowman in the same ways. And different ways to implement the same functionality, the same game mechanics with the same narrative premise, using roughly the same number, the same structure, although slightly different programming here, to replicate the same passage structure within these three different examples of space exploration implemented in Harlow, implemented in SugarCube, and here, as I've talked through in this video, implemented that is within Snowman 1.3.